Good morning, everyone. My name is Yuri Schmitke. I'm the president of the Brazilian Association for Energy Recovery from Waste, ABREN, and the president of Waste-to-Energy Research and Technology Council, WtERT Brasil, and partner advogados. I have a master in law and public policy from UniCEUB, and write the book. The name is Waste-to-Energy as an environmentally appropriate form for disposal of municipal solid waste. And now we're starting the second ABREN International Webinar Waste-to-Energy Technology. Vamos começar agora o segundo Webinário Internacional sobre Tecnologia de Recuperação Energética Waste-to-Energy. Vamos falar em inglês neste evento, mas você que está nos assistindo agora, fique à vontade de nos mandar perguntas para os canais da ABREN. Nosso e-mail abren@abren.org.br, estaremos à disposição para tirar todas as dúvidas. The organization is from ABREN, and we have the support from Global WtERT Council, BDA, Martin, Itachi, Kinin, BW Expo, Energy Hub, Ambiental Mercantil, Agenda Urbana Brasil. And now I want to call for Dr. Edmund Fleck to talk about waste-to-energy, an established part of waste management in Germany. Edmund has 30 years experience in waste-to-energy. He's the managing director of Martin and currently Martin Technology. He's a director of Martin Biopower, PTI also. He's the president. He was the president of ESWest, European supplier of waste-to-energy technology from 2004 and 2019. He's a member of ISWA working group on energy recovery. He's PhD in mechanical engineer from the University of Minnesota, and have a master in physics from the Rheinland-Westphalia Technological University, Aachen, Germany. Please, Edmund, have the word. Edmund, just have to put microphone. Yes, that's it.
I did this. Well, good morning. Thank you very much for letting me give this presentation on waste to energy. I hope that you can see my presentation. If not, please let me know.
Yes, you can share the screen again. The same procedure.
It's not shared?
Yes, the green button. Share the screen in the Zoom.
Okay, sorry. Yes.
Okay.
Even though we have also been in home office for quite some time, I must admit I'm not that used to this. What I will talk to you about is that waste to energy is an established part of waste management in Germany. Basically 4 big topics. I will talk a little bit in the beginning about the statistics and some regulations which are valid to this industry in Germany. Then I talk about waste to energy development over the years, and there were some technological options. The major part, I think, will be waste to energy, what's reality in Germany today, and then draw some conclusions. Germany has about 83 million inhabitants. It's a little bit over 350,000 square kilometers, so quite small compared to many other countries, especially to Brazil. We are a federal republic, 16 states, where some of these states are cities like Hamburg, Bremen, and our capital city, Berlin. So when it comes to waste arisings in Germany, then the majority in 2018, which are the last figures available, the total waste is about 420 million tons, of which a majority was recovered, and quite a few of that was recovered thermally, which means in some kind of incineration plant. When you look at the details for 2018, these 420 million tons, what is of interest to our discussion today is basically these, what is called Siedlungsabfälle, which is municipal waste or similar waste, about 50 million tons total. Majority, like in many countries, is obviously construction demolition waste, which is almost more than half of that. So of these 50 million tons, there were 33 million tons were material recovered and about 15 million energy recovered, which is basically waste to energy, which we will talk about. Per capita, you see what every German generates in terms of waste in 2018, 455 kilograms, which does not include electronic waste. And you can see here what are the different big fractions. This is biological waste, about 120 kilograms. This is material for recovery. This is basically the almost 160 million is MSW. Majority of that is obviously then be going to waste to energy. And there's a little bit of large waste and some other waste streams. So per capita, we have about 450 kilogram per capita per year in Germany in 2018. Quite a bit of waste that we are generating still. Regulations. This is not true for Germany alone, but for all of the EU member states. All regulations come from Brussels. That's a very straight and very clear rule. Regulations are drafted in Brussels, they are passed eventually, and then they have to be put into national law in every EU member state. Typically, there's a 4 or 5 year time frame for each of these regulations where they have to be put into national law. The only drawback is that there are no really good sanctions if countries don't do that. Some member states are a little bit more active doing that, some are not, so there's not a lot of good sanctions. Germany is playing a very active role in Brussels in the legislation, especially in waste management, and many of the rules or the data taken, the limits, etc., are taken from German experience. I've been very active in Brussels myself as president of ESWET, the European Association of Waste to Energy Technology Suppliers. There you see a lot of German people from the government that are very active in supporting new regulations. In Germany itself, waste management is responsibility of the federal government. So the federal government, based in Berlin, is drawing the rules, and then each of the states, each of the cities in the end, it trickles down the way, have to really play by these rules. So it's a very clear structure. It's a very good structure, in my opinion, that you really have a federal government saying what the way forward is, and then basically it trickles down to the local level. What are the main regulations in Germany at the moment covering waste, and especially waste to energy? This is only a shortcut. There's one that was passed in 1993, Technische Anleitung Siedlungsabfall, which is shortcut TASI. This is a technical regulation for waste. Basically what it says, you have to stop landfilling of waste with more than 5% loss on ignition. So it's not a straight on landfill ban, but it's basically indirect landfill ban, because normally municipal solid waste or anything else like that has more than 5% loss on ignition, so it's no longer allowed. The big issue at the time, and I will come back to that in the later part of the presentation, is that it went into force in 1993, but there was a transition period of 12 years for this law to be taken in effect. And this was a very, very long period, which led to a lot of shift in the regulations, in the technologies developed. Very important for waste to energy plants is what is called the 17th BIMSCH, the 17th Federal Emission Protection Ordinance, which basically regulates all the permit conditions for waste to energy plants, which is emission limits for certain pollutants, which is minimum oxygen content, etc. So this is really the main law that governs the permitting of waste energy plants in Germany. It has been, it's quite an old law in the end, but it has been last changed in 2013. And there will be a change pretty soon again, based on the recent discussions on the BREF documents in Brussels, in Sevilla, which ended last year. So there will have to be a change of this ordinance. This is one really very much to remember. What is important, and I think this is not only in Europe, but it's worldwide now, is circular economy. In Germany, we have it called Kreislaufwirtschaft, which literally means circular economy, which clearly says we have to go away from the habit that we had for many decades to really use products only once, but try to keep them in the economy as long as simply possible and feasible. Again, this law describes a lot of things, but among others, recycling rates for packaging waste, for municipal solid waste, etc. This came into force in 2017. And again, it's basically a law coming down from the Circular Economy Directive passed by the EU some years ago, and then being trickled down into German law. Waste to energy, it's not very new. I mean, in the Middle Ages, in Europe at least, people threw their waste out of the window. So you had very dirty streets, you had all these, hygiene was very bad. And this caused a lot of headache and a lot of diseases. The first waste incineration plants, I wouldn't really call them sometimes waste to energy, but incineration plants were built in the late 19th century. In England around 1870s, in Hamburg, in Germany, in the end of the 19th century. So these were very simple plants, obviously, but already they had some electricity generation. There was some district heating use, and they even used the bottom ash, as you can see here, to bake bricks. So a lot of the concepts that we have today have already been put into force then, that you make use of the energy in the residual waste that you cannot recycle anymore in some form, and then also use the materials that are left after the incineration for usage. So again, a concept that that is very important today, but nothing that we really have our generation has invented, but has already been in place in the late 19th century. There are some pictures of plants which obviously around the turn of the 19th to 20th century, which were quite messy because they were sometimes batch type. People had to feed the waste by hand. People had to take out the residues afterwards by hand. So this sometimes later on you had like a carriage where you took out the bottom ash. It was all very simple, but it was a concept that was working. There were a few plants in England, in Germany, in Denmark, but it didn't really last. Waste to energy really only started in Germany, but also I think across Europe after the Second World War, where basically the economy was good enough, so there was enough money available. Landfill was considered to be not the best option. And so there was also a drive to make use of waste as much as possible, of materials as much as possible. So this is where basically it started in Europe and in Germany as well in the late 1950s. As I said before, with the setting in force of this technical ordinance for waste in 1993 and the very long transition period of 12 years with no landfill tax, so there was no charge, no nothing happening in between. There were many other options that were being considered because, as it is still the case today, and as you know in Brazil and all over the world, waste incineration was by many people not looked at very favorable. So there was mechanical biological treatment plants being developed in Germany especially. There was a lot of discussion on alternative thermal treatment processes, and I will talk about that. What we obviously want to avoid, what is not an option, is what you can see here. It's landfilling. I mean, these are pictures from some places in the world. Landfills, people are living off landfills. They are getting into fire. This is what happens if waste collection doesn't happen in the city. This is in the south of Italy. So basically in the heart of an industrial area. This is not what we want. And even the green people that don't like incineration, they in 2010 published a report in NARTEC in the United States where they clearly say end of disposal of waste from human cell on landfill sites. This is what they said for 2020. I think we more or less got there in Germany, that waste that still contains biologically active material is no longer being dumped on landfills. So, mechanical biological treatment. As I said before, landfilling of biodegradables stopped in mid-2025. At this time, we had a green social Democrat government, and they don't like waste incineration. So there were some developments of mechanical biological pretreatment plants. Some plants worked, sometimes some plants failed. There are still quite a few in operation today. And the mass balance is basically you can recover some metals, which is good. You have some loss of evaporation because you need some heat, basically some evaporation to drive off the water. There is still, and this was a change that was allowed by the law, that you can still landfill the low calorific fraction. And then there was something that was considered in the early days to be something valuable, a high calorific fraction, because you drive off the water, so you increase the heating value. And this was supposed to go to coal-fired power plants and to cement kilns. And in the early days, when these plants were developed and the business plans were made for the projects, there was even thought that they would get a positive fee, so you'd get paid for the high calorific fraction. We have about 50 plants in operation, 6 to 7 million tons of MSW go in there. And the remainder is about 50%, as I said before, that are remaining after this treatment. What you have to remember, though, is that the heat energy content totally is almost not changed. I mean, there's some rotting, some carbon, chemical reaction. So that you generate heat and then you drive off the water, but the energy content is still more or less the same, and especially the material that makes non-recyclable waste a difficult waste. Organic materials, contaminants like chlorine, fluoride are still in there. So they are still basically a material that has to be taken off very carefully. In the end, coal-fired power plants did not like this because they had very much afraid of corrosion in their boilers. And cement plants are taking only a very small fraction. These figures are from 2012, but they have not changed dramatically over the years. So basically what happened in the end, that for these 3 to 4 million tons, we had to build, in the end, waste-to-energy plants after all. They are not called waste-to-energy plants, they are called RDF or secondary recovered fuel plants, but in essence, they are the same technology and the same type of material like waste-to-energy plants. And again, I like to cite this presentation by Mr. Welzin about mechanical biological treatment. And I only want to draw to the conclusion at the bottom, this technology is an intermediate. And what we have seen in Germany in reality is that because of the economy, that they cannot sell the high calorific fraction, but they have to basically pay a fee for that. A lot of the plants have been shut down, or once they are reaching the end of life, they will not be replaced, they will just be torn down. Thermal treatment of waste, there are 3 basic processes. It starts basically with pyrolysis, goes to gasification, there are different possibilities, and then combustion. And basically you can see this here. It basically starts with pyrolysis. There's no air injected, so there is no oxidation happening. Gasification, there's an incomplete oxidation happening, so you create a combustible gas that you still might use in a different process. And then you have straight incineration or combustion, where you completely oxidize all the burnable material. There was a lot of discussion and a lot of hope to have so-called alternative thermal treatment plants. As I said, pyrolysis. This is based on a study, these figures that ISWA did some years ago. I was part of this working group where we looked at different of these technologies. There's about 25 plants worldwide based on pyrolysis of, again, municipal solid waste, mixed municipal solid waste, non-recyclable waste. The capacity is very small, about 1 million ton, mostly in Japan. Gasification, again, it's a single stage, which means there are plants that are having a gasification stage and then integrated a combustion stage, which is not really the main, there's not really big advantage in terms of compared to incineration. There are around 50 plants, again, small capacity. 2-stage gasification, which create a syngas, a combustible gas, which can be used for something else. There are even fewer plants with a very small capacity. And plasma gasification, which is just one means to gasify the material, there's even less plants. When you compare this to MSW, there are more than 2,000 plants in the world, and which more than 100 million ton of per year capacity. So we're talking about much larger numbers and much larger experience and proven record. So again, Mr. Welzin says these technologies have not shown reliability so far. This was in 2010. I don't think this has changed at all up till now. There have even been more plants losing money, people trying to get this working, but it doesn't work for mixed municipal solid waste. Now, a short intermediate Martin company. We are a small company based in Germany. This is our head office where I'm sitting right now in Munich. We are almost 100 years old, family owned. First generation, the founder, second generation, third, and the current fourth generation. 100% family owned. We are definitely one of the main companies in the waste energy sector since 1925. This is a picture from the patent application in 1925. And this is one of the largest plants in the world in Amsterdam, 6 lines. So we have a lot of experience and we have a large reference base, and it might be interesting to know that the first 2 plants on our reference list have been built in Sao Paulo. I mean, they are no longer in operation today, but this was in the late 50s, the first 2 plants. And then we built plants in Munich and more in Europe. So what is great combustion? It's rather simple as shown here. You have a feed chute where the waste is transferred from a bunker to the feed chute. And then it's basically pushed by a device called a feeder onto the grate itself. There's combustion air from below, primary air going into, combusting the waste, and then the bottom ash, the burnt out material, is dropping down at the end. The not completely burnt out gases are then oxidized by secondary air, and then they give off their heat in a boiler to either drive electricity, a turbine generator, or to give it off as steam. So this is a very simple picture of the combustion system. A total plant then can look like this. This is like a horizontal grate in this case with a boiler, and then the very elaborate flue gas treatment to meet the emission limits that are very stringent and very tight, not only in Europe, but in most of the countries in the world where these plants are being built. They want European standard emission limits, which are quite low emission limits compared to many other industries. Some pictures of plants. This one is in Ingolstadt, a little north, about an hour north of Munich. 3 lines total built in these years you can see here. 1 line at Zellamelis. This is in Thüringen, one of the new federal states in Germany. Coburg, also Bavaria. Mainz on the Rhine River. 3 lines. And again, Mr. Welzin citing that Advantage is a proven technology for many years. I mean, this was something amazing for a green person to say, and he is not something, he's a scientific assistant in the parliamentary group in the Bundestag, in the federal parliament, to say when using with best available technology, there's very low environmental impact. So I think it's something that speaks almost for itself. What is the waste capacity in Germany that we have right now? We have about 70 plants that are straight waste to energy plants, capacity about 20 million tons. And then we have about 30 plants, or what I said before, these plants built basically to take high calorific fraction. It's called Ersatzbrennstoff, RDF, secondary recovered fuel, some high calorific material developed from MSW by some pre-treatment process. The capacity of that is about 25 million tons per year capacity. And at the moment, the last years, the usage was basically 100%. At the moment, we are burning in Germany year after year about 25 million tons of non-recyclable municipal solid waste or waste from commercial industry. We export a lot of energy. We recover close to 500,000 tons of metals, ferrous and non-ferrous, and there's quite a substantial amount of savings of CO2. The 6.5 million tons, 6.5 million tons, sorry, is about the CO2 emitted by 600,000 people. It's clear we cannot save the energy problem in any country. There are projections that maybe if you have a good energy recovery rate, you can maybe have 3 or 4% of the electricity need covered, no more than that, but we can make a very valuable contribution and especially avoid landfilling. So what are the conclusions? Waste to energy and waste to energy plants are definitely an integral part of German waste management. There is a lot of opposition that is not changed at all. Working close with the public is obviously very essential to inform them as early and as open as possible. The market in Germany is mainly replacement. There's almost no greenfield projects. There's also no capacity increase, but mainly to replace lines that have now become 30, 40 years old, which is a typical lifetime of a waste energy plant. And for the technology, it is grade-based plants that are the technology of choice because they are proven, they're reliable, and they are there to basically make use of the energy and the materials in ways that cannot be recycled in a sensible way. And I think 25 million tons in a country like Germany speaks a role. There is very clear statistics that say we only take away from landfill, we don't take away from recycling. We want to really use the waste that is not recyclable anymore, that is at its end of its lifetime, and avoid landfill. And with that, I thank you very much for your attention.
Thank you, Edmund. Excellent, good presentation. And I have said to everyone that was assisting us in this webinar. At the end, we have 30 minutes to, you can make some questions to us in YouTube Live and we'll give the answers. Now, I want to call for Christian Cordome to talk about the role of waste to energy in both sides of the channel, France and United Kingdom. Cordome have 30 years of experience in the environment and energy sectors, vice chair of ISA Working Group Energy Recovery. He's a member of the Scientific and Technical Committee of ISWA, Development Director at Clean Environment and Energy Sector. He's former Deputy General Manager at Labs SA, whereas he worked from 2001 to 2012. He's a member of FTST, OFATE, RMRC, RISPO, PREWIN, and United Nations Task Force for Air Pollution. He's an engineer graduated from Minis Paris Tech, France. Ms. Cordome, have the word.
Thank you very much.
That's great.
Just a moment. Can you hear me?
Yes, that's nice.
Okay. So it's okay. So thank you very much, Yuri, and thank you very much, Edmund, for your presentation. In my presentation, I will focus on both sides of the channel, so France and United Kingdom, and to compare a little bit the story between these two countries, where we have a lot of energy from waste. Could you see the next slide? It's okay? Okay. So just a few words about CNIM, CNIM in English. We are mainly turnkey project designer and supplier for environment and energy, and especially renewable energy. This is the type of plant that we are building, this energy from waste plant for Sheffield in UK. But we are also involved in biomass to power, for example. And for waste, we are also building mechanical and biological waste recovery with sorting and composting, or sorting and material recycling, just as this brand new plant that we have built and that we are operating in Paris, which is sorting, in which we are sorting almost completely automatically material from the selective collection from Paris. It's a 45,000 tons per year waste. In total, all the plants that we have built are recovering the material and energy from municipal solid waste of 110 million people around the world. This is a view of a plant that we have built in Torino, Turin, in north of Italy, close to the Alps. This is more or less 500,000 tons of waste, which are treated in this plant to deliver power and heat to district heating. You can see there a photo of a car, a sport car, because this architecture has been done by a very famous Torinese guy, which is Bertone, who is designing cars, but who has also designed the architecture of this facility. Another architecture that you might know, because it has been shown on the broadcast and so on, which is Copenhagen. In this plant, we have built with our subsidiary, LAB, which is the leader for flue gas treatment. The flue gas treatment, you can see on the left here the scrubbers and the flue gas treatment that we have built there, and condensation. And 200 million people in the world have their waste combustion flue gases cleaned by lab process. This plant is famous because the architect has designed this plant to have a ski slope, artificial ski slope on the roof. I recommend you to have a view on this on YouTube, where you could see a freestyle skier going down this this plant. It's very surprising to see such sport there, but it can accept the public to have some skiing. So if you visit Copenhagen, you can have some fun on the roof of this plant, which is only 1 kilometer away from the Queen Palace of Denmark. And to finish the presentation about Klim, we are also operating facilities. This is the example of Baku in Azerbaijan, which is the very first energy from waste plant in this area that we have built turnkey and that we are operating now for 20 years. And we are also operating plants in France and in UK. So let's talk about the waste to energy situation on both sides of the channel. So for those who are very far from Europe, the channel is the sea between the United Kingdom and France. So first about the status in France, and then what has happened in UK recently. A few words about technology and waste to energy impact on greenhouse emissions. So first, a few figures about France and UK to compare. About the number of inhabitants, you see it's around 67 million inhabitants. And the amount of waste which are produced is between 31 to 44 million tons of waste, municipal waste, both in the two countries. So it's very similar for these figures. From this waste, about 11 to 12 million tons, so it was 2015 figures, are thermally treated. So it's the same, very similar. But you could see there on these figures that some differences. First one is that we have much more plants in France than in UK, more than 129, and compared to 56 in UK. And the average age of the plants in France is 25 years, compared to 13 only in UK. So some difference there. Another difference is about the energy production, mainly electricity in UK, and it's a cogeneration in France. So electricity and heat, you could see there 24 terajoule compared to only 1 in UK. So just a moment. It seems. Excuse me, we were a video just started.
Okay.
So it's better. You could see on this map, which has been done by the CEWEP, which is the Association for the Operation of Plants in Europe, the number of plants by country and the amount of waste which are thermally treated by these plants in million tons. So you could see once again 40, so it was in 2017 there. You could see there in Germany, the 96 plants, almost 130 million tons of waste, 27 million tons of waste burned in Germany. 95% of these plants are using great combustion, as Edmund has informed us. This graph is very interesting from CWEP, once again, coming from official statistics from Europe, Eurostat, comparing the shares between landfilling in red by country, then in orange waste to energy, a share, and in green recycling and composting. You can see in average in Europe that we have 23% of waste, municipal waste, going to landfill, 28 going to waste to energy plants, and 47 for recycling and composting. This is the average for European Union. In United Kingdom and France, this is quite similar. There is 17 to 19% going to landfill compared to 21 in France, and 35% going to waste to energy in both countries. But in Germany, as Edmund has shown us, 31 is going to, almost nothing is going to landfill, as it is the case in Sweden, in Denmark, or in Belgium. On the contrary, on the other side, you could see Eastern Europe countries where, like Greece, for example, 80% of the waste are going still to landfill. This is another way to present the figures with a trigram, recycling, landfill, and thermal treatment. And you see the two dots for United Kingdom and France. You could see there countries where there is a lot of landfilling, and the best of a class where there is almost no landfilling. On this figure, you could see that there is no countries with 100% thermal treatment. It's always a mix between recycling and thermal treatment, which is the good solution to treat municipal solid waste. To finish the comparison, you could see there on this graph the average capacity of the plants. So it's only 120,000 tons per year in France. It's quite small, but we don't have a very dense country. In the United Kingdom, it's about the double, 230,000. And if you compare to Netherlands, where it's almost 600,000 tons per year for each plant, it's rather small, but Netherlands is a very dense populated country. So the situation of the waste treatment in France, first we have to separate and to look differently two types of waste. First, commercial industrial waste. You could see on these figures on the left industrial waste and on the right commercial waste. Sorry, it's still in French. And you could see that for this type of waste, it's quite easy to recycle material. You could see there 67% of industrial waste which are recycled, 11 million tons, and only 10% of the waste which is going to waste to energy facilities, but only also 8% going to landfill. It's quite easy to recycle such waste, and it's rather similar also to for commercial waste. It's rather easy to recover the material in this type of waste because it's homogeneous, more homogeneous and less polluted in general. So it's more easy for the industries to recycle the material inside. In the number of, if we have only a look to the number of facilities in France for the waste treatment, you could see that there were a huge number of landfill in brown there. It was about 500 landfill in the 90s. And there was also a huge number of very small facilities for waste to energy. At this time, it was without recovery, very, very small facilities. Some of them which were only working during the week, were stopped during weekend or even stopped during the night. So after very strict regulations coming from Europe and applied in France, most of these plants have been closed to install flue gas treatment, and they have been replaced by much larger facilities. It's the same for landfill. They have been, the small ones, and especially the uncontrolled ones, have been closed to change for sanitary landfill. And we could see there, of course, an increase of sorting facilities and composting facilities at the same time. But this number of facilities is not the most important point. The most important one is the capacities. You could see there that the facilities without energy recovery, so only with the combustion of the waste, has decreased to almost zero and has been replaced by much bigger facilities with energy recovery, efficient energy recovery, to go up to almost 15 million tons of waste treated in the 2016-17. So we have closed the small facilities, installed flue gas treatment, and have larger facilities there to replace that. And at the end, for municipal solid waste, so not commercial industrial waste, we have a mix of solutions. So about 38 million tons are, so this is municipal solid waste, 38 million tons are going to treatment, 32% are going to waste to energy facilities, 16% to organic recovery, and 10 million tons to material recovery. So in total, we have 75% recovery with these three types of treatment. Still, in France, we have 9 million tons, 24%, without any recovery going to landfill. You could see that waste combustion without any energy recovery is only 0.2 million. So it has been reduced to almost zero. But still we have landfilling in France. With the material recycling, it has a very interesting impact because 66% of the paper which is used in this industry is coming from recycling. 50% of the steel is coming from metal recycling. 58% of the glass is coming from recycling. The only product where it's difficult to recycle is plastics. Only 6% is recycled in plastic industry. And the plastic which is the most easy to recycle is plastic bottles. Plastic films and things like that are extremely difficult to recycle. At the end, in France, when we compare the shares between energy from waste, recycling, and landfilling, you could see that the landfilling has decreased, but slowly. It was 13 million tons, and now it's 8 million tons. You could see an increase, but very small, of energy from waste, and an increase of composting and material recycling. It's more or less flat because initially we had a lot of facilities in France, and we have improved the working, revamped them for flue gas treatment, and increased the sizes to obtain this result. The point is, because of that, a lot of facilities, you see 100 facilities, have an age higher than 25 years. Even 1/3 of the waste treated in France are treated in waste energy older than 35 years. So this age needs to revamp some of the plants, and we have quite a few plants which are brand new. Some examples of revamping that we have done in France. This is a plant close to Versailles, in the Paris region. This plant has been built 45 years old, initially 45 years old, with 2 lines. We have built then boilers. We have built a 3rd line, installed flue gas treatment. And in fact, the two old lines, 45 years, have just been replaced by line 4 of 12 tons. So the total capacity of the plant has not been changed, but we have changed the energy efficiency, the energy recovery with a brand new turbine, and replaced completely the flue gas treatment with, it was a wet system, we have changed it for a dry system with NOx treatment. So you could see this very difficult work of revamping, because this plant was still in operation during all the, so it was initially like that. the two old lines with line 3, and we have replaced these two old lines by line 4. But the plant has remained in operation during all this extension. Another example of revamping is Rambert-Villers. It's in the east part of France. We have called this plant Phoenix. We are working for Suez on this plant, who are supplying the shoe-to-stack, a new line of 10 tons per hour and new flue gas treatment. So you see the operation. There are very few greenfield plants in France. Troyes is a plant that we are just building now. It's the first one since 2011 as a complete greenfield project in France. We are a turnkey supplier for Veolia. It's a public service delegation, so it has been financed by Veolia. And you see it's a small plant, very small plant, 60,000 tons per hour. So it's technically possible. It's quite expensive to build such small plants. It's much less expensive as a gate fee to build much bigger plants. But in this area, it was a good solution, nevertheless. In France, it's the 50th plant, 50, that we are building in France for a total capacity of almost 9 million tons per year. A last example of a new plant in France. This is in the island overseas, the island of La Réunion, so close to Madagascar. We have obtained this contract to build a plant which will burn RDF, which will be prepared on site, 140,000 tons, more or less, of CSR, which is the French word for RDF. And this RDF will be prepared on site and then going to the waste energy facility to produce power. So let's compare to UK. In fact, in 2004, the situation in UK was completely different from France. 70% of the waste were going to landfill. It was a landfill country. And if we compare to today, it was very similar to Romania. In Romania, you have 70% of the waste going to landfill. So you see, less than 2 decades, the situation in UK was completely different from France. To catch up with France, they have a lot of work to do to reduce this landfill. Why they have so many landfills is that they have a lot of clay quarries to have the bricks, and then at the end of the life of the quarries, it's a very nice landfill site. So it was very easy and non-expensive to use this old quarry. So how did they manage to close the landfill in UK? They have put in place, so it's a different way from Germany where there has been a ban, but in UK they have decided to put in place a landfill tax. Initially it was quite flat. It was around £10 per ton. So £1 is about 1.1 euro, $1.2. It was quite flat and it was not moving very fast. We have built the first modern energy from waste plant in UK in '94, but this regime of landfill was not very incentivizing the market. Then they have decided in 2004 to increase this landfill tax of £8 per ton every year during 10 years. And to have so 80 pounds per ton in 2014, and now it's with escalation. So in 2020, the landfill tax is £94 per ton, so more than 100 euros per ton. And in the law, it's written that it will not decrease. And as they have put in the law directly in 2004 that they will increase with this slope, this landfill tax, it has given a very good visibility of the market. The private companies in UK were able to know that 10 years away, landfill will not be any more competitive because of this landfill tax. And with this visibility, and they know that it will not change because it was with escalation afterwards. And with this visibility, it was possible to go to private financing and to build facilities to avoid, to be more competitive than landfill compared with this landfill tax. So in fact, the first solution, an easy solution, was to ask your neighbor. Of course, on the continent, we have, as we have seen, a lot of energy from waste plants. So it was possible for UK to export a part of the waste on the continent. And this is what has happened. And it was following more or less the slope of the landfill tax. You could see here the landfill tax slope. And you could see here the increase of prepared municipal waste going to the continent by boats after bailing, mainly to Netherlands, Sweden, and Germany. And it has reached more or less 3 million tons of waste going to landfill. It was an easy solution because there were a need of waste, especially, for example, in Sweden and Denmark, to produce heat. And it was cheap at this time because the sterling was very high in value. But with a Brexit, so it was 1.5 euros per pound. But with a Brexit, it has been going down to 1.1. Therefore, he is not very happy because it's not a good solution. It's not so inexpensive solution. So they have to build facilities now. And this is the solution, is to build facilities in UK. And during more than a decade, you could see the waste market, the construction of energy from waste plant awarded by countries in Europe. And you see in 2010, 2019, in the period 2010-2019, UK has been by far the first market for the construction of energy from waste. 44% of all energy from waste plants built in Europe has been built in UK. And you see Sweden is number 2, but with much smaller, and France is number 7 with 4% of the capacity awarded. So a very, very active market because of this regulation. And the effect of that regulation was very, very impressive. There is a huge success. You could see the 70% of landfill that I have shown you at the beginning here in 2004. And it has gone down to 6 million tons of waste. And this success has been obtained by a mix between energy from waste, you could see there in blue, and material recycling and composting here in green and orange. There has been also a decrease there. You could see this is the export of waste, the decrease of the total amount. But nowadays, this export is reducing and reducing because of the Brexit. Another presentation of this result, you could see there the landfill, which has been reduced by minus 75% in 15 years. And the mix between material from waste and energy from waste to replace landfilling. Of course, this is meaning that most of the plants in UK are less than 10 years old. As you could see on this graph, as you see 8 million tons are less than 10 years old because this is a brand new park that has been built. Some examples of plants that we have built there in British Islands. The first one I have told you was Selship in London, which is 1 mile away from Tower of London, built in '94. It was a merchant plant that we have built together with Veolia. And then a series of plants that we have built in the 90s and beginning of the 2000s. You could see there. And then there was a new, after this regulation for landfilling, beginning of 2010, there was a new period of construction of new plants. And we have built a number of plants for FCC, Veolia, Viridor, Sita, MVV, Viridor, and so on. And now Will Liberator, which is a new client for us. And the last 4 ones that we are finishing to build: Park at Fair for Will Liberator, Avonmouth for Viridor, Earlsgate that we are starting for Covanta Borkwell, and that we will operate also, and Lostock for the joint venture between CIP and FCC. In total, this is 24 turnkey energy from waste facilities that we have built in British Islands, with a total capacity of 7 million tons, so 37% market share. One difference between France and UK is that most of the plants are under private concessions. So you could see this is the breakdown of our contracts by clients in the last 2 decades, so since 2000. 32% of the plants that we have built have been built directly for municipalities in public tenders. But then you could see important concessionaires and private companies, especially in UK, so Veolia, Suez, Viridor, Liberator, that are our clients, especially in UK. I know that my dear friend Roland will present something else after me, but this is our market share in the CNIM European countries where we are working, so excluding Germany and Switzerland where we are not working. My friend Roland will explain something else afterwards, but there are a few competitors working in this topic, especially coming from Europe. So you see the result in UK. In fact, the tendency is similar in Europe. You see a decrease of landfill, minus 31% between 2001 and 2016, replaced by energy from waste in orange, and recycling, plus 11% waste to energy in this period, and plus 19% recycling. So this is recycling and waste to energy are going hand in hand to replace landfill. I remind you of the objective that Edmund has told you initially. There is an objective of reducing landfilling down to less than 10% in 2035 in Europe, and to have recycling up to 65%. So we have to continue this road. I don't go too much in details with the technology that Edmund has presented you. So this is, for example, the plant in Oxford. You could see the flue gas treatment is very different from the one that Edmund has presented you, because it's a dry system with lime, and a DeNOx, which is done in non-catalytic in the furnace. But the principle is rather similar. So in this type of plants, we have a combustion system. We are in partnership with Martin since 1961. And then after the combustion system, we have furnace and boilers, produce steam, then the steam power cycle, and the flue gas treatment. I will say a few words about alternative thermal treatment, because there was a promotion and experimentation of this alternative thermal treatment in UK with subsidies to promote this type of technology, especially gasification. If you could produce syngas with a good a level of calorific value, you can obtain subsidies. You can have gasification on a grate. We have done together with Martin some experience. On a grate, if you stop secondary air, you have incomplete combustion and you have gasification, and you could have a syngas there. So it's a gasification, but it's also a state combustion. Like almost all the gasification which are promoted by the market, especially in Japan. Some of them are based on fluidized bed, some of them are based on shaft furnace, and you have at the end thermolysis or pyrolysis if you reduce completely the air injection. You could have plasma assistance in fluidized bed or in shaft furnace. But at the end, all this technology, a very important difference with the great combustion is that they need preparation of the waste, which is always very difficult with residual mixed solid waste. So at the end, the technologies which are used for residual municipal solid waste, so you could see here the figures for the number of plants in commercial operation over 5 tons per hour in all the continents. So you see the grade is more than 90%. A few fluidized bed, which is needing preparation, especially shredding, especially in China there, or with RDF. A few gasification, mainly in Japan, and pyrolysis and very few plasma. In the last decade, the plant awards you see 92% of plants awards were based on traditional advanced grade that we are proposing together. 5% fluidized bed and 3% gasification or plasma gasification, especially in Japan or in UK. In Japan, more than 90% of the plants are based on grade system. The European Union, through via its Science and Knowledge Service, GRC, has published this paper concerning waste energy technical potential. And they are saying that gasification, so this is official paper from Europe administration, they say that its gasification have not been commercially proven to date, even with extensive pretreatment of the waste to get the better homogeneity. And this is very important point, is that residual municipal waste is not homogeneous, it's variable, and that there have been mainly costly failures of gasification and pyrolysis in Europe. There are a few plants working in Japan, but Japanese wastes are very different. And at the end, the few plants which are working, they don't have a higher efficiency in energy recovery. A very interesting example in UK of failure is Tees Valley, which was one of the largest plasma gasifications. So this slide was coming from the supplier of this plant, Alternergy. So you could see here the gasifier with plasma. It has been built by this company for air products. A huge facility, 2 times 300,000 tons. You see two plants there. But in fact, late 2016, the newspapers were saying final nail in the coffin of Air Products site. And Air Products has quit the market of energy from waste and has lost almost $1 billion on this plant, only this plant. So it was a huge technical disaster. It was absolutely not working. And they have lost this amount of money only 6 months after the beginning of startup. So it was not working at all. And it's not the only failures in UK that we have seen with gasification. Energos company has built 4 plants of a great transport system with gasification. They failed. NEAT with pyrolysis or Autotech with fluidized bed. They stopped to promote this gasification in UK, and now the subsidies are very reduced in UK to go in this type of plants. Exactly at the same time in Tees Valley, we have built a non-alternative but an advanced energy from waste in Wilton. In Teesside, it's 5 kilometers away from Tees Valley, plasma gasification. And after 3 years of construction, it has been commissioned and it's working. It's 50 megawatt electrical like normally with Tees Valley plasma gasification, but this one is working. It's non-alternative, but it's advanced. So sometimes I take this paper from the president of ISVA. We have a round wheel, it's working. Some people are trying to have a square wheel, but it's not working properly. To finish, I will say a few words about greenhouse gases. A part of our energy is sustainable because we have biomass. Much more than 50% of energy produced is coming from biomass and therefore is biogenic and non-fossil. So it's renewable energy, and it has a very interesting impact on greenhouse gases. So let's take the example of UK. In fact, in the 90s, waste sector, which is in orange there, so you could see the greenhouse gas emissions in UK by sectors: power, industry, transport, building, and waste. It was more than 9% of the greenhouse gas emissions. So it's not nothing. In general, we are talking only about industry or transport or of course, power, but not about waste. And because of the construction of all the plants, it has been divided by 4. You could see the curve there. Because landfill is emitting a lot of methane, which is 25 times more, which has a warming potential 25 times more than CO2. And therefore, the landfilling of waste has a huge impact on greenhouse gas emissions. And you could see it was 9% in UK. Now it's less than 3%. It has decreased. It has been divided by 4. So it's a huge success there. And you could see there that they claim that the annual reduction of greenhouse gas emissions for the waste sector in UK was minus 9% per year during this period. And you could compare this to the increase of landfill tax of plus 10%. It's very similar. So it was very, very efficient policy in 15 years to obtain this result. This is not the only example of greenhouse gas reduction. For example, Copenhagen in Denmark is claiming that in 2025, it will be the first CO2 neutral capital in the world, with 100% renewable and recovery heat in district heating. And this district heating is representing 98% of the city's demand. Every citizen in Copenhagen is connected to district heating. And in Denmark, they have decided to stop completely fossil fuel boilers to do the heating for the city. And they have replaced coal-fired power plants to a brand new biomass plant, 500 megawatt thermal wood boiler there, where we have supplied the flue gas condensation to a very high energy recovery. So it's very similar to a small natural gas boiler condensation, but it's a huge plant. And the other plant for the waste, Amager, that I've shown you with the ski slope there. But it's very interesting also because we have flue gas condensation. So we recover all the heat coming from the vapor in the flue gases to have very high energy efficiency. And so to finish, waste energy is a part of circular economy. You could see there on this graph coming from this report from ISVA, Circular Economy, Energy and Fuels. It's a part of the final sink of the circular economy. We have pollution in our waste, and the only thing to avoid this pollution and to take out all hazardous components in the waste and to isolate them from biosphere is to have waste energy, which could be concentrate all this pollution. And it's very important to keep the circular economy clean. We need to protect the circular economy from hazardous substances. And we need this financing, and waste energy is the solution to do that, to have circular and to avoid circular pollution. So to conclude, in resume, you could see that the energy from waste situation between UK and France are similar for a number of figures like population, the amount, the treatment share, total capacity, the great combustion technology as a standard. But it's very different because, in fact, UK has caught up with France for energy from waste. So therefore, the plant age, capacity of a plant, the number of plants are different. It has been, and it's still a very active greenfield market. And with the Brexit, the market is still very important compared to a few brownfield projects in France. It's different because it's private market. So you need to be competitive compared to landfill. And this is the landfill tax effect there. In France, we have public tenders or private tenders as public service delegation. The point is that there are very few cogeneration in UK, much less than in France, nevertheless much less than in Denmark. There is some RDF export. We have another type of RDF, which is CSR, but which is not very developed in France. And finally, there has been some promotion of alternative thermal treatment, but a lot of failures, and this experimentation is now finishing. So finally, energy from waste is a very compact, clean and secure waste solution that you could install in urban areas close to city centers and delivering a renewable energy and very good to avoid greenhouse gas emissions from landfill. And just to finish, this is the example after the Copenhagen example. This is a very nice example of a plant which is in the city center. This is Monaco in the south of France. Monaco is very famous, of course, for the prince, which is living there in this palace, for the aquarium, which is there, and for the Formula One circuit, which is around the harbor. But it should be also famous for this plant, which is there, which is the energy from waste. This is treating all the waste of Monaco, delivering heat, cooling, and electricity to the Principauté. And most of the waste are going by underground collection. So people, they don't even know that there is an energy from waste facility there. Thank you very much for your attention.
Thank you, Cordon, for your presentation. It was very, very, very nice. And I want to call now Roland Grail. He'll talk about Roland will talk about Hitachi project. He's the senior sales director at Hitachi Zosa Innova. He's a Switzerland with 30 years of experience in project management and engineering in waste management and plant construction industry. Please, Roland Grail, it's your time.
Okay. Bom dia a todos. And thank you, Yuri, for introducing me. And thank you to ABREN to invite Hitachi Zosa Innova to this webinar. I will have a bit of different topic. I will talk about technical and commercial requirements for global waste to energy or energy from waste solutions. So I will present the latest development, most recent development in new markets, and explain the environment and the condition needed to realize projects. So that is the topic of my presentation. So first introduction of the company, Hitachi Zosa Innova. So we are based in Switzerland. So I'm sitting in Switzerland, in Zurich right now in the office. We have subsidies in several countries: Germany, USA, UK, Slovakia, and France. And we are in total about more than 800 employees. Almost 600 sitting here in Zurich, or let's say paying on the pay list on here in Switzerland. And we are more than 80 years in this business. We belong to a Japanese group. That's why we have our name, Hitachi Zosen. Comes from our parent company, which is in Osaka and Tokyo. And we know each other for a long time. So Hitachi Zosen used our technology on a license basis since 1960 and built the plants at the beginning in Japan, later in other Asian markets. So our original name was Fonroll, and we became part of that big group in 2010. So today we are together and cover all energy from waste markets in the world. So our parent company mainly covers the Asian markets, and let's say we cover the rest of the world. And in some projects we work together. Here you can see I probably have not updated the latest project. It's changing so fast, especially the projects in China. So this is the project that we have delivered together on a global basis. And you can see we have quite a nice market share over the last decade in all these markets, in the global markets, energy from waste markets. All this is counted on capacity basis, not on order intake amounts or whatever. It's capacity. So, I mean, we had heard about this EU Circular Economy Package, which is aiming to 65% recycling by 2030. So waste should be separated, recycled, organic fractions separated. We have their solution, that is the anaerobic digestion, to recover the biomethane and material as compost and liquid fertilizer from these solutions. And for the non-recyclable inorganic, mainly inorganic fraction or post-recycling fraction, we have the thermal solution, where we recover energy as power and heat and material from this waste from these sources. Other material goes directly to recycling. Best is to recycle directly at the source, to separate at the source, and to bring it as a clean organic fraction to the AD plants or for other recycling uses. So then we have the two solutions. We have the thermal solution shown here, municipal solid waste, or RDF, or CDR called in Brazil, used to generate electricity or heat in the best case, if you have that possibility, or process steam, and recover materials from the input material. Organic fraction goes to our compogas technology. So over there we have food waste and green waste, which is digested in aerobic digestion. And afterwards, the biogas used to generate electricity. But in the best case, to clean it, to upgrade it from biogas to biomethane. Also, for that, we provide the technology. We have the technology in-house as well for that, and use this biomethane as a combustible to drive cars, trucks. So these are the two main solutions that we have in our portfolio. Here a bit our solution in the context of renewable energy. So energy from waste in the bottom is producing base load, covering base load, producing heat and electricity, same as other power plants. And then we have the anaerobic digestion, where we can produce energy on demand because we can store the biogas. And then we have the fluctuating, let's say, renewable energies as wind power, solar power. And you have some periods, of course, where you produce too much energy, that is electricity that is not needed at that time. So we have also solution for power to gas. So we use that excess energy in electrolyzers, produce hydrogen, and take CO2 from the AD plants and energy from waste plants to produce biomethane. And this biomethane can then be used again, if needed, to produce power or to use it as a combustible. So you see, we have the technology from energy from waste to thermal solution, for the biogenic fraction, the anaerobic digestion, power to gas to combine it, and gas upgrade, gas cleaning system to clean the gas from anaerobic digestion, but also from landfill or from other sources. This is our core technology. So it's our proprietary technology. You see here the whole combustion part here, combustion section. The waste is fed into this chute. The boiler, heat recovery here, and then flue gas treatment systems, residue handling and residue treatment. So all this is our proprietary technology, which is implemented into complete plant, into turnkey deliveries. So we have our proprietary technology, and of course we need other technologies which are not our own technology, but where we do quite some engineering that is for energy use. That means the water steam cycle part, a balance of plant, all these auxiliary systems, and electrical and control system. And on top, of course, you have the building civil works part, where we do not do any engineering, there we just manage those civil work packages and integrate everything in a complete integrated solution for turnkey plants. So we are a technology provider, but well, due to the recent development over the last 15 years, became more and more also an EPC contractor. This was mainly driven, as Christoph explained before, I think, by the UK market, where there was a high demand for EPC turnkey deliveries. So a bit about the international market development. Here I'm just showing actually the Hitachi Zosen Innova, the Zurich, Switzerland-based company. I do not show the projects managed and handled and delivered directly by our parent company. So you see in green, this was for many, many years our core market. Europe, as Christoph explained, the UK was the most important market over the last, I would say, 15 years, at least 10 years. So we have just recently contracted there the plant number 13. Hopefully we will be lucky with that one. And now it's a bit changing. I mean, UK is still a very, very important market, but the most recent developments we have are in other markets. So I will talk a little bit and explain the situation in Turkey, in Istanbul, the plant that is in construction right now. I will talk about Russia, about the development in Russia, the 4 projects in Moscow, and the 5th project in Kazan. One of the newest, most recent signed contracts is in Australia, the Rockingham project in Western Australia. We will also present that project and the environment, the project development of that project. And so these projects are all in construction. And I will also then come to Dubai, Middle East countries, talking about the ongoing development and activities in the Dubai project. I will go a little bit to Americas. I mean, in America, in the US, we basically have no energy from waste. So this was a market which was not much happened there in the years. But now it became active in the renewable gas sector. So here I will present 2 anaerobic digestion projects. The same in Sweden, just show it. And we have it even in China. So we even delivering anaerobic digestion plants to China. China is also, let's say, maybe it's an important market, but a less important market for us. Most is handled directly by the Chinese companies. Many of them have licenses from European technology suppliers like us. But for the big plants, we actually delivering the combustion grades from Europe to China for these plants. So you can see over the last, I think it's 5 years, we have delivered 44 combustion grades for 14 energy from waste plants in China. There's a total capacity of 37,000 tons per day. The same in Thailand for 1 project. Smaller projects, they basically do everything by themselves or get it delivered from our Japanese parent company, which is a different grade, which is not that grade that we deliver here. This is a most recent development that we deliver here. I will not show the project in India. We have also developed the project in India. We see also India as a good opportunity. There we have everything developed locally, manufactured locally to 100%. So it's a low-cost plant, everything done locally without us being directly involved in the execution from our headquarters in Zurich. Istanbul, that is the situation in April. So Istanbul is an EPC job. So we deliver the plant as an EPC and technology supplier to the municipality. This project started in September 2017. So we see the main equipment is installed, boilers are installed. Boiler pressure test was in March and April, and now we are completing the water steam cycle, air-cooled condenser here, and the whole building. It's quite a special architectural design what this plant will have. Some more details here. So this will be the largest turnkey project ever awarded in Europe. It's 1 million tons a year. So a big plant. It will all then become the largest energy from waste plant in Europe. We do the EPC together with a local partner. The Turkish partner company Makyol is a Turkish partner. So this is basically what we do in all the new markets. Of course, we team up with partners that have local experience, of course. Makyol is covering the civil works mainly, and together we do direction of all equipment. Important to mention in this project is this was a project initially covered by a supplier credit insurance by the Swiss Export Credit Agency, which is called SURF. You may know, I mean, there were some turbulences in Turkey in 2017-18, which made it necessary to find another way to finance during the project, to finance this project. So SURF supported this new financing solution, long-term financing by a buyer credit insurance, which was then implemented, I think, about a year ago. So this buyer credit insurance, as you see, it covers the financing of Swiss export by domestic and foreign banks and financial institutions. So before it was financed, the financing was organized basically by the Istanbul municipality, and we brought together with the help of SERF another solution there to continue, which was very critical. I mean, we had an insurance, so in case we would not get paid anymore, we would have been compensated, but then the project would have been died. So this was the way to save this project and to continue. So now it's on a good way and will be continued. Another development, it's in Russia, Moscow. So here we are talking about 4 plants. You see in all directions, we have one plant. So the waste is collected in the city, going to transfer centers and then transported to the 4 energy from waste plants. So these plants are all in the Moscow region, which is called Oblast, not in Moscow city. So they're around the city, because you cannot build in Moscow, you cannot build new plants in the city. Quite big plants. The first plant we got awarded in end 2019, and the second project was just started this April. Here, the environment is very different. I mean, this is mainly driven, this project is mainly driven by the Russia's energy strategy for renewable energy sources, which had a target to have 4.5% by 2020, but with renewable resources. I don't know where they are with this target actually. So as the project started a little bit later, most likely this target will be reached later. So what they introduced is a so-called capacity payment. So this plant can generate 70 megawatt. So for the 70 megawatt installed, you get paid. You get a green tariff for 15 years of operation. It doesn't even matter what you produce. You can even produce a bit less. So you get paid by the installed capacity, not by the power output from the plant. This is a DBFO project. So we designed it, built it, and it's financed by our client, which is an SPV, and we will also participate in the beginning in the operation of the project. This project, I think it's very special here. It's called this investment, this so-called investment agreement. So there is a fixed tariff for gate fee, and the waste amount, the quality is guaranteed by the municipality, by the government, also for the 50 years of operation. So here, this project, we don't act as an EPC contractor. It's also a quite challenging market to be in Russia. So here we're providing our, let's say, our technology, the key equipment that I have presented in a previous slide. And the power is sold to the market. So there is no special power purchase agreement. So it's sold to the wholesale market. Now we jump very far away. Now we go to Australia. Here we have something similar that what we heard before from the UK. So they have introduced landfill taxes, called here landfill levy rates, and they have different rates from depending on the region. What is shown down here is from Western Australia. It's here's Perth region. So this is today at 70 Australian dollars, which is about close to $50 today, and will increase in the next year, each year by, well, it's not decided yet, by 10 or 18 Aussie dollars. So that's why you have these green extras here on top, depending if they go to the high amount or the lower amount. Other regions like Southern Australia, here, this port in Adelaide, they are currently at about $75. And in Sydney area, New South Wales area, they are already at well, about $100 here, this level here. So this was the driver for this project, so similar to the UK market. And because of that, I mean, here on the bottom, you see also today the average landfill cost in Western Australia, so this part, is around a bit more than $100. And the project where we were contracted, that we developed, is in this area, in the Perth area here. So also this project is a DBFO project. We as HDI actually started to, no, we did not start. We were invited in 2016 to join the team, which was New Energy Corporation and Tribe Infrastructure, to join the development team and continue the development. In 2018, I think it was in January, we signed or we won a competition for a first waste contract. And then from that point on, we continued the development of the project until the financial close of this project in January this year. So it took us 2 years from signing waste contracts to have a financial close and start to build the plan to realize the project. So here, this project we're doing also with a partner. Here we joined with Acciona later then, and we built together as an EPC team this plant. Here, I mean, the context is a bit too complex to explain all the details. It's very, very complex. I mean, we have this 20 years waste contract, the one that I mentioned before. But there are several. There are in total 4 different waste contracts. No, 3 waste contracts actually. One even with the operator, which is together with us, Suez. They will also deliver part of the waste, and about 1/3 is acquired on the market. But the other waste have 20 years contract duration. There is also a contract for 20 years for the incineration bottom ash to be used in road construction towards aggregate. So there's also a contract with a company that is using that material to build roads. And then there is a 8 years power purchase agreement with an industrial off-taker. The numbers about gate fee and electricity price are confidential. But for you to understand in what level we are, I have here the wholesale market price of electricity. So this is the price of today. And if you see the landfill cost here, you can also guess where the gate fee of that for that plant is actually paid to this plant. But the numbers, official numbers are confidential, so I cannot show. But it's on that level. So it's a very, I mean, at the end, we have to maybe close about, I think it was more than 20 contracts to come to the financial close. So, and you're doing that all at the same time. So you can imagine people involved in such developments, in such financial closing are very busy. So it's very tough. So you're basically on, well, 24 hours, 4 weeks, and very tough to close all these contracts at the same time. So here we actually are on 3 levels. So Hitachi is on the SPV level. So we own part of that plant with a minor share. We are in the EPC team, and we, together with Acciona and together with Suez, we will also operate that plant. So we are all levels involved in this project, which is quite difficult than just to be a technology or EPC supplier. This project is not yet in execution. Here we are actually in this phase where we are aiming to the financial close. Very challenging. Many people involved in that project. Well, the expectation for sure is that we will close it this year. In the best case, already in September, I would say. So this is a different setup. This is a BOT project. So we will build, the plant will be built, operated, and then transferred after 35 years to the Dubai municipality. So this will be the largest resource recovery facility worldwide, actually. It's huge. If you see the numbers here, it's about almost 2 million tons per year, and which is very impressive because I think in Dubai, I think a bit more than 3 million people are living in Dubai. So it's a lot of waste what they're generating. And unfortunately, there is no separation, no recycling at all. So in this plant, really all the waste will go to this facility. Maybe this will change in the future, but it will not be the case. So here also we were part of the development team. So we developed that project together with partners, and we will, together with also an experienced company in that region from Belgium, but has a lot of experience in the Middle East, be the EPC together, and also the O&M team operating this plant for 35 years. It's a very high efficient plant. Temperatures are high in Dubai. Now in the summertime, you can get, I think, up to 50 degrees. So incredible hot. So you cannot really go outside. And nevertheless, but of course, at a lower temperature, we can generate up to 194 megawatt of electricity. So it's a big plant. So you can also invest a lot in the very, very high efficient turbine, and that's a power plant turbine, a two-flutter turbine, which allows you to reach such high efficiency rates. I compare that with another project on a much bigger place, actually, for Mexico City. This slide is in Spanish, but I think you can understand. So this is the amount of waste that the Mexico City is generating per day. And they're doing quite well today. So they already separate organic fraction for composting. They separate the recyclable fractions. Actually, during the collection, they're doing that. And then they have some separate mechanical separation and some different waste fraction what they separate. So the remaining fraction is actually this 8,600 tons per day, which goes today still to landfills, several landfills around Mexico City. Also not in the city area, of course, or in the city. So that's a big amount. Almost the same amount, a bit more than what is going to the Dubai plant. So, and for this waste, it was intended to build an energy from waste plant for part of it, actually for 5,000 tons per day. So the rest should be then reduced by further recycling and by further separation of organic fractions. So actually out from this 8,600, so another 3,600 is the plan to be separated as organic fraction or as recyclable materials. And then the remaining, so let's say about 40%, less than 40%, 35% of the total waste amount would then go to this plant. So this plant would then treat all the non-recyclable, post-recycled waste in Mexico City. So it was intended to be, well, probably the first plant in Latin America. Unfortunately, this project is on hold. So the development started already in 2015, the waste competition, the competition for the concession in 2016, and the concession agreement, the so-called CPS, the service contract was closed in 2017. And then we worked towards the financial close. So we were not really ready, but almost ready, almost finalized by the end of 2018. But you may know that there were elections. So a lot of projects have been put on hold. And well, we will see when we will continue. Hopefully we can continue. Eventually, well, there might be some changes, but actually this contract is still in force. So this concession agreement with the city is still in place. It's also a big facility. I mean, this is very important for this kind of project. I mean, to make it viable. I mean, you have to think big. I mean, it would be very, or even more challenging in all these places that I have presented to realize small plants. So this is also quite a big plant. Also high electrical efficiency. And as I said, they have these contracts. I mean, our client has a contract for 30 years of operation. So, and we would also together be the local partner, be the EPC contractor delivering that the project to our client, which is Thermo WTE. Mexican companies and also participation of Veolia. What is the key for this project is actually the way it is set up. I mean, the conditions. I mean, the city budget will be unchanged because what the city today pays to bring the waste to the landfills, which are not owned by the city, and to buy power, electricity for the subway system. So the same amount of money is available for the operator, for the owner and operator of this plant. So the city budget would not be changed, it would remain the same. I show you here some numbers here. So I mentioned this contract, this service contract called CPS. So it's for 30 years. And for this amount of waste, for this amount of energy delivered. So all is included in this contract, service contract. The plant itself will produce a bit more, will produce, can have a higher throughput, can produce more gigawatt hours, which will be sold to the market. So at the fee, what they would receive, what the city had to pay is $130 million per year for that service. And this payment, and this is also very important, was also guaranteed by a governmental fund. So this makes it actually pretty simple and safe to finance such a project. So you can also calculate what it means, what the cost per ton per waste is, assuming a certain cost for the landfill. I mean, the current landfill cost in Mexico is probably around $20. So if you would calculate that, with that throughput, you would have a kind of electricity price of around $100 if it would be paid by the electricity itself. But it's an amount paid in monthly rates, guaranteed for 30 years. So here's just shortly our development in renewable gas and anaerobic digestion. California is very active in this using of the greenhouse waste. Also here, it's our development. We have developed that project and we operate it and we own it. A smaller project, of course, we could not do that for energy from waste plants, where the investment is at least a factor 20 higher than it is for this kind of plants. We have done the same in Sweden. That is the second project. The first project was an EPC delivery, and we've acquired a company there already having an anaerobic digestion plant, and we will replace it with a new project, which is also in construction right now. In China, I mean, we're working together with German Bioenergy, delivering the technology for anaerobic digestion plant in China. As I showed in the previous slide, this was the first project, and in total we have currently 3 projects in China to already delivered or being delivered. Here, this is a bit to summarize what I showed in all the projects before. So the revenues for the project can be very different. You see here a project where most revenues comes from electricity sales, and where you have quite a low revenue from the gate fee, the waste delivered. And of course, you can always have generate some revenues from the metals, ferrous and non-ferrous metal that you separate. Here in this project, I mean, it's all in the concession, so you get paid a fixed amount and you have some extra income from the metal sales and other, let's say, extra energy that you're generating or electricity that you're generating or extra amount of waste that you take to the plant. In other project here, it's you have this, it's obvious which project it is, of course. It's the capacity payment, so you have a fixed tariff paid by the government, and then you sell the electricity to the wholesale market and have a small portion gate fee. Actually, in most projects in Europe and also in this project in Australia, typically it's the other way around. I mean, 2/3 of the revenues are typically coming from the gate fee, and 1/3 is from power sales. So this means every project is different and has a completely different environment, and but it can work in different ways. That is shown here. So these revenues, of course, this is what you get here. Then you have the operating cost. I mean, you have the fixed operating cost for the workforce, administration, all this. Then you have the variable operating cost. It's the consumables, the residue disposal, and the maintenance cost. And of course, you have the financing cost. This can have a very big impact. So you can imagine the financing cost, for example, in Mexico City project is not the same as in a Dubai project. A big difference, and this can have a big impact. So actually, at the end, what you need here, the net waste treatment cost, this is what has to be covered by the gate fee or by subsidies or concession payments. So of course, this can make a big difference here. What is finally needed as a gate fee or subsidy to make this make a project viable. What helps a lot is, and that we have in this project here in Switzerland, if you have the possibility to not only produce electricity, but also to use the heat, the steam in nearby industry. Here it's used in a paper mill. So by doing this, you can use 75% in this case of the energy in the waste and generate revenues for your project. So this helps a lot. I mean, in other places, not unfortunately not in the UK, but in Switzerland, in Scandinavia, all plants are producing power and heat for district heating purposes. And of course, this cannot be used. You could also even produce district cold. There's a plant in Spain, Barcelona, which is doing that for the nearby office buildings, producing in a centralized cooling system, the cooling of those buildings. I mean, here's a bit to summarize what is really needed to make a project happen. I mean, there must be some incentive, subsidies, or some political decisions to make this kind of project happen. I mean, we heard already about the solution in the UK, which started with a very low landfill tax, which was increased to a very high landfill tax today. So this caused all this development. This was the driver to develop all these projects in the UK in the last 15 years. The same happened in Australia, where we have today, depending on the region, gate fees of $48 to $100. Israel is doing something similar. I mean, they have collected landfill taxes over several years. So they have a fund now with this money, and now they start to build plants. So there will be public tenders. The pre-qualification is ongoing now for the first project. So they have plans to build 5 projects within the next 10 years, and then another maybe 5 projects for the years to come. And this money will be available as a grant for the winner of that competition. So that company that will use the lowest grant, so the lowest money, the lowest grant subsidy from the government will win that competition. So you could get up to 70%, I would expect, of the capex, of the cost of the plant as a grant from the government. And this grant, as I said before, was filled by the landfill taxes collectors in over the, I don't know, 10 years maybe. Other countries, I mean, we heard that before, also Germany, many EU member states, also Switzerland, had landfill bans, so there was no other solution, so you had to do something else with your waste. There is this capacity payment, this green tariff in Russia, in Moscow. Mexico City, also special model. I mean, there it's not the market price to sell energy. It's actually the price to buy energy, which is the basis for the concession fee. Grants I already mentioned. Also in Australia, we had a very small grant for that project, but it was only in the range of maybe 5% of the capex. Important also in many places, especially it's also the case in Russia, it would also be the case in Brazil, especially preferential tax treatment to get some tax reductions, very important. Attractive funding solutions. So I mentioned this ECA, Export Credit Agency, covered the financing, or green investment funds could also be an attractive solution to make a project viable. And then, of course, governmental support and governmental guarantees. Well, I don't go into detail. This is just to show the typical structure. So I mentioned here the developer of the project. Well, actually, those here up here are the sponsors or the developers of the project, and they will hold the shares in the special purpose company here. And as I said, in some project, we are in Dubai, also in Rockingham, we are here on that level. We are together with a partner, the EPC contractor, and we are also the operator, together with a partner for those projects. And you need a lot of other contracts. I mean, here you can only see here's the waste, here's the power purchase agreement, maybe agreements for the residue. So very complex. So you at the end, you have easily, let's say, between 12 and more than 20 contracts to be managed and to be closed and negotiated at the same time. So very complex. And this is basically the same thing, whether it's BOT, BOO, DBO, it's about this similar setup actually. Here a little bit to explain the use of the funds. I mean, you have here the capex of the plant, the financing cost, which can vary a lot. And you have the development cost and a certain reserve that you need because of some unexpected reasons. So this in total is the cost of the project. And then on the financing side, also depending on the conditions, I mean, it can vary a lot. It can be the equity that you need from 20 to maximum, I would say 40%. I've never seen 40%. So typically you're more in the range of 25 to 30% as equity. And then the rest is financed by ECA covered debt, multilateral banks, financing institute, by development banks, institutional investors, and incentive programs. So this is more or less what you will need to finance the project. So this is the key factors which have an influence in the bankability of the project. So at the end, you always talk to the lenders, so they bring most of the money, so they don't want to have the risk, so they want to have a clear allocation of the risk, and this is typically transferred to the EPC and to the O&M contractor. So it's very, I mean, we can go through it. I mean, of course, the legal environment, of course, is very, very relevant. I mean, is a risk, case of risk management. It must be a well-defined remuneration scheme for the gate fee, for the residue payment, well-defined terms for waste management services, a very clear definition of the waste, of the quality also as well, because the quality, I mean, if you get the amount of waste, but not the heating value that you were expecting or that you had agreed, then you cannot generate the same amount of electricity, of course. So here it's also a deliver or pay condition for this part. And of course, the counterparts are relevant in this aspect. Then you need long-term off-take agreements, as I mentioned before, for power, residues. Also here the counterpart, the quality of the counterparts is relevant. Here it's also a take or pay contract. So if they don't take, they have to pay anyhow, as here. If they don't deliver, they have to pay. Then of course you need the approved technology, which we have. I mean, Christoph mentioned that, what approved the technology is. And experienced contractor, because banks or lenders will not like to do that with someone that has not real experience and not a good track record in building a plant. And the same goes for the operator of the plant, of the O&M contractor, also very relevant. And of course, at the end, you must have a economical, viable project. So here you can see it again. I mean, this high risk, low risk technology, mature, proven technology, very relevant. Plant construction, experienced contractor that has a good track record and technology. So here it is really, because at the end you will have this lenders advisor, technical and legal advisors looking into all these details and finally decide whether you get the financing of such a project or not. So if you have the wrong partners, if you do not have a strong team here, you will fail at the end and you will not get the financing. Construction of this plant is quite complex. So here's a project in the UK. We have built it 2 units first and another 2 units, totally 480 megawatt fuel input, replacing a coal-fired power plant, which is just behind that side. Very complex, and you see the duration mentioned above. So it takes around at least 42 months to build such a plant. And you can also build it in the middle of the city. This is a plant in Paris. So the Eiffel Tower is just to the right, about 3 kilometers from this location. To realize this plant, it took even more time, very complex. It's two-thirds below the ground, just at the River Seine, so very complex civil works construction here. But here we delivered only the technology, we did not deliver the complete plant. So to get an idea about the overall time frame to develop and build a project, I have mentioned some information here. I mean, you have the first step there where you need to define the project. You have to find the right site to build it. You must have some feasibility studies. Then you typically have a public procurement process, public tenders. You need time to prepare the tenders. And you finally, if you're lucky, you get the waste contract or the concession agreements. And then it is not over. I mean, you cannot immediately start to build the plant. Then you need all the agreement, all these contracts that I mentioned before, the environmental licensing, the permitting. And once you have all these documents together, you will invite the lender's technical and legal advisor. So you do not typically not choose them by yourself. So the lenders, so the banks will choose that, but you will pay for it. And that is another process. You must have finally the green light until you come to the financial close and can start the construction. So here in this case, I would expect the total duration from, let's say, first activities until the plant is in commercial operation of around 9 years. And don't forget, which is very important, the development cost. I mean, to develop for all these stages here, only the external costs, you can, well, you should consider about at least $10 million to be spent over this period. Means if you do not come to the financial close, you will lose that money. But this is only external costs. So on top of that, you have only the internal costs. So the cost from us as an EPC contractor or an end contractor, from the sponsors. So all these involved parties have internal costs, which is not considered here. This is really only to pay the external, also to pay this lenders, technical and legal advisor, which can be very expensive. And all this is at the end recovered under the project budget. So this is what I showed before. This will be part of the financing. Thank you for your attention.
Thank you, Roland, for our presentation. It was very nice. And now I will give the word to the debaters. They will ask some questions. The debaters, it will be Flavio Matos, waste management expert with 15 years in environment and energy sectors, members of ABREN's board of advisors and secretary manager of WtERT Brasil. He's a member of ISO working group Energy Recovery, master in environment and energy institute minus telecom France, masters in management, Polytechnic University of Madrid, Spain, and PG in project finance, Middlesex University, UK, and BSc in mechanical engineer, UFU Brazil, certificated by ISO International Waste Management. And next, we'll ask for Antônio Bolognese. He's graduated in electrical engineer from Escola de Engenharia Mauá. He's a specialist in thermoelectric generation from UFSC and MBA in energy business from Fundação Dom Cabral and master in administration from PUC Minas. He's the CEO of BSG Valore SA and Opperman Engenharia in Consultoria Ltda, project and business development companies in the energy and waste area. He has worked for 40 years in the electrical sector, and he's a professor of GVSP with a postgraduate degree in the area of infrastructure. And he's the vice chairman of the board of ABREN. And we ask for the third debater, Rubens Herbert IB, is the vice president of Brazilian Association for Energy Recovery from Waste, ABREN, first secretary of Waste to Energy Research and Technology Council, WtERT Brasil. He's the Brazilian citizen, bachelor engineer in chemistry from ETH Zurich, and experience on financing in environment sectors in UBS, ABB, and WWF. Please, Flavio, have the word, please.
Thank you, Yuri. Thanks to a lot to all the speakers, Mr. Fleck, Mr. Grail, and Mr. Cordon. The presentations have been very, very much interesting. I do hope they will help make people in Brazil understand the importance of waste-to-energy technologies as part of a sustainable waste management system. So on my side, I'd like to mention that in Brazil, there are lots of myths around these waste-to-energy technologies. As in many other countries where this has not yet been implemented, and even those where it has. These myths are usually promoted by associations that fight waste to energy, but also landfill owners. And one of the old beaten arguments they keep repeating in Brazil and also elsewhere is that most of municipal waste should be recycled and composted, and it would be an absurd to promote their destruction with waste-to-energy technologies. Well, we know that the ultimate goal of a perfect waste management system is to recover all the recyclable materials, to compost the organics, and then to limit to a very minimal amount the rejects that would be finally disposed of in landfills. However, in order to reach that, municipalities must first implement, first of all, selective collection, which is not the case very much in Brazil, for all different waste streams on households. So once this is in place, the population must also be educated and separate the recyclables and the right dedicated bins. And finally, there should be a major manufacturing market to purchase and reuse all the materials that have been sorted, which requires very high quality materials, as we know. The recycling chain presents significant technical, social, economic barriers. For instance, if you assume a given municipality provides separate collection for 70% of the municipal solid waste, then 70% of the citizens do the correct separation. And then finally, we have 70% of the materials that are actually recovered into the production chain. So if you make 70% times 70% times 70%, it gives only 34% of materials that would actually be recovered into the production chain. Then the remaining above 66% of these rejects would still require a final destination. And we know that according to the waste management hierarchy, energy recovery has clearly the priority over landfills. Also, if we look at the latest figures from Eurostat, which is the European statistic body, it indicates that Germany thermally treats around 31% of its waste, while almost 67% is recycled or composted. While in Switzerland, you have 48% more or less thermally treated and about 52% recycled or composted, with almost zero landfilling of non-pre-treated waste. So Mr. Cordomo has also showed that since 2001, Europe has increased recycling rates from around 30% to 50%, while waste-to-energy rates have increased from 15 to 25%. And landfilling has been dramatically reduced during the same period, down from 55% to 25%. So I'd like to hear both from Mr. Fleck and Mr. Grail, how such rates of recycling and composting have been possible with so much thermal treatment both in Germany and Switzerland. If we were to believe these waste-to-energy opponents, it would be very, very difficult to understand these numbers. So if you could give us an explanation on that on your respective countries, I would very much appreciate. Thanks a lot.
Well, if I can take the start, Edmund Fleck here. I mean, the rates that are being reported for Germany on recycling are in some ways a little bit misleading because of the way of the calculation has been done in Germany in the past. They did not really calculate what is being recycled in the sense of really going back into the material cycle, but the recycling rate published was a recycling where it was material that went into some recycling process. This will change with the new circular economy law passed in Europe, and so the numbers will change somewhat. On the other hand, if we look at waste management from the beginning, I mean, a lot depends on our own behavior. Waste is not coming from somewhere magic, it's coming from all of us, from us as citizens. Our behavior of consuming, our behavior of what we want as products, etc. So we are in a lot of ways responsible for the waste that is being created. There's a lot of materials that are very composite, that contain different material types, which are easy maybe to manufacture, but very difficult to separate afterwards into fractions that then really go back into the material cycle. There's things like paper, where it's known that they can be recycled only a certain number of times and the fibers are too small, so they have to be taken out of the circle. There's some material that reaches its end of lifetime. So I think a lot depends on our own behavior, a lot depends on sorting at the source from us, materials like organic material that can then be composted and make a quality compost that can be reused. You can make a lot of so-called compost from mixed municipal solid waste, which cannot be reused. So it's of no use in the end. We as an industry, as a waste to energy industry, we are not up for numbers of capacity. We are saying we treat whatever is not recyclable, whatever society in the end leaves, to avoid landfilling this material. So to recover the energy contained and the material. We are not at all promoting capacity as such. And we can deal with a lot of different types of waste, a lot of different waste fractions and compositions. The technology that we have is very versatile, very flexible. We don't need certain materials in the waste stream. We can live with whatever is left in the end. So we are absolutely not against recycling. We are against landfilling. That's the main point. And the numbers, as was pointed out earlier in Germany and across all Europe, the trend, I think, is clear. Thermal treatment and recycling is not is complementary. It's not contradictory. The numbers itself might be difficult or different in the past because of different ways in different countries to count them. They might become more comparable in the future when the new circular economy law takes place. Thank you.
Thank you very much.
Thank you. I would like to give the word to Antonio Bolognese, please.
Yuri, can you maybe let Roland speak about the case of Switzerland?
Yeah. Speak. Okay, Roland, have the word, please.
I mean, what we do in Switzerland, we just bring material to the recycling that is separated at the source. So only what is separated in the industry, in the restaurants, at your home, that is going to the recycling industry. So what is once mixed together doesn't go to recycling anymore. There are very few exceptions in some parts of Switzerland, but we just separate. And this is, I mean, this is a long story. I don't know exactly when it really started. Most likely more than 30 years ago, maybe separating paper, cardboard, then glass. And today we are separating, I don't know how many fractions, electrical waste, batteries. So this is a long process coming to such a high recycling rate. So it needs education. People have to get used to it. And still today, I mean, you can still see people that do not really separate, but most of the people do, because if they separate this fraction that go to recycling, they reduce their cost for the waste disposal, because all these fractions that you can either bring back to the shop, to a recycling place, or that are collected in front of your house, of your apartment, this is free of cost, also the organic. But what you put in the remaining waste, which is go to the combustion plant, to the energy from waste plant, for that you have to pay. You pay a buyback that you put into the container. You have to pay. It's about for 35 liters. It's different from place to place, but it's around $4 to $5 per 35 liter bag. And this helps to come to these recycling rates. Just by your purse. I mean, the people don't like to pay, so they separate waste. But this took a long time. So this is not something that you can implement and you have in place from one day to the other. So I think if you start increasing your recycling rate, and what you should do for sure, you should not wait, or you cannot wait to build solutions to treat waste that is non-recyclable, or if not, it just goes to the landfills, and this is definitely worse for our environment, for our global climate. So you have to develop both at the same time.
That's great. Thank you, Roland. Please, Antonio Bolaez.
Okay, thank you very much for all speakers, Mr. Fleck, Mr. Cordon, Mr. Gale. And here in Brazil, we are fighting a good war for several years and trying to bring to Brazil new technologies to treat waste. And as we could see in all presentations, there are several ways to treat waste, as composting, recycling, thermal treatments, landfill, producing RDF, and several others options. Unfortunately, here in Brazil, we are still almost landfilling of our waste. We are recycling only 3%, and the part of the landfill, it's not only exactly landfilling. We are landfilling only 56% more or less. The other part we are putting in a dumping ground, almost 20%, and the other 20% more or less we are putting in the wrong and the bad landfilling way. Okay, it's very important for us to have the experience from the Europe here in Brazil, because the people, in majority of the people, don't understand what happens to the waste. And I was glad to hear from the green people from Germany that they agree that waste to energy is a good way to treat the waste, and including Mr. Fleck said that MBT or mechanical biological treatment is not a complete treatment. It's like an intermediate treatment, and the green people agree with this. It's very important, because there are a lot of people that has a wrong idea about MBT. Then I'd like to know from Mr. Fleck, what's your view on the effectiveness of MBT or for MSW without separate collection, as it's currently the case in Brazil? Open the microphone
Okay, sorry.
Please.
Sorry. Well, as I said, this was the big hope in the 1990s, early 2000, that MBT would be a sensible solution compared to incineration, because as I said before, incineration was not wanted. So MBT was looking, because it has the name of mechanical and biological. But the essence for me is MSW is containing a lot of different materials, and a lot of materials that are potentially polluting our environment if they are released. So somehow you have to contain these pollutants. That's why we as citizens have to deliver our MSW to the community to treat it properly. I mean, we are not the owners of this waste, we have to give it to them. As it has shown, I mean, MBT is, you can mechanically separate some of the materials that has not been selected at source, like metals and some glass can be selected prior to the MBT process. But then you have this process itself, which basically you're converting some of the carbon into heat, into energy, thereby driving off some of the water, but that's about what is happening. So you're still ending up with a high calorific fraction, which still contains, as I said, a lot of the pollutants. So you don't really solve the issue. As you said, Mr. Bolognesi, it's a pre-treatment, it's an intermediate step, but not the final solution. The solution that was envisioned in Germany was to bring it to use it as a fuel, but unfortunately the users that were intended did not like it in the end for various other reasons. Cement industry was afraid of contaminating their product with some pollutants. The coal industry was afraid of corrosion in their plants because of the high steam parameters and the high chlorine content. So today in Germany, MBT is an intermediate that is running out because the issue is you have a high calorific fraction which has to be incinerated. You cannot landfill it, you have to burn it. So there is no real use. You're adding money on top of for treatment while you can do it in a waste incineration plant in one step. So as I said before, MBTs in Germany, there's no hype anymore and there's no new plants. Basically, they're being phased out. The issue for me is always, if you have any process, whatever it is called, you have to look at that you get a sellable or a usable product out of it, otherwise to bring the material back into the circle, because otherwise it's a sham recycling or a sham recovery. And this is basically what happened with MBT in Germany. Thank you.
Thank you, Edmund. Give the word to Rubens IB. Please, Rubens.
Well, thank you very much. Thank you very much to Roland again, to Edmund, and to Mr. Christoph as well. My last question will be quite short, and it's also regarding a very big misconception in Brazil that we have. Here we have our biggest opponents to waste energy and incineration. There's this big misconception that the more you incinerate or the most you recover from waste, the less you recycle. But that seems to be a paradox, and as a matter of fact it is. And my question is to Mr. Cordon, because as we see in Brazil, we just have a bit of composting, mostly landfilling and dump sites, and our recycling rates are about 3%. On the other hand, in the countries that you have waste energy technologies, you have around 40 or 45% recycling, and these rates are much higher, as we have seen in those graphs. As you also might be aware, we have a very, very big number of waste speakers here in Brazil, who are the biggest responsible for recycling what is actually recyclable. My question to Mr. Cordon is like, how can we demystify this reality and show that if we bring waste to energy technologies, we're first not getting out their jobs, we're not undermining recycling rates, actually happens the opposite. There is this big misconception. I'd like you to, just if you have a message for those sector and for those people who recycle, how can you say, how complementary is this technology, and show that we're not against them or anything like this? That is my question. I try to be as quick as possible. Thank you.
Thank you for this question. This is very important because it's not only happening in Brazil. We have faced also this problem and this difficulty also in Europe and, for example, in France. There were rag pickers in France. They were participating to the collection of waste. Everything was completely mixed. They were very annoyed initially when it has been when the first trash cans have been implemented, for example, in France, by an engineer and prefect, which was named Poubelle, Eugène Poubelle, who has given his name to the trash can here in France, Poubelle. They were very unhappy because it was closed. And for them, it was much more difficult to do the recovery of materials in this Poubelle. And then when the first incineration plants have been built in France at the beginning of the 20th century, it was also a sort of competition. And you know, rack fight is the fight which is very tough. Nevertheless, in fact, the conditions where they are working are terrible, because they are really in the pollution. The impact for the human health of these working conditions are terrible. There have been a report from the ISVA, so International Solid Waste Association, showing that the dump sites and with the rack pickers who are living on them, almost 60 million, so almost the French population equivalent, they have disease and their health, which is really alterated by the conditions of living and the condition of working directly on these dump sites. It has been shown also that the disease coming from these conditions are more severe than malaria. We are giving money to malaria to decrease, but unfortunately, we're not giving, the public administration is not giving enough money to reduce this terrible thing, which is the dump sites. So there is a program from ISVA to close these dump sites, which are in general the worst polluted places in the world, and also which are leading this population to very bad health conditions. And when we are building waste management, correct waste management in these countries, and this has been the choice in China, this has been the choice in Europe or in Azerbaijan or in the Middle East, then we can allow these people also to have jobs, because we can create infrastructure with correct conditions of working for the sorting of the material, for example, coming from a selective collection, for the collection by itself also, and we need more people to do these collections, of course. And the conditions of working and the conditions of living of these people are much better. For example, in our sorting facilities that we have implemented in France and that we are operating, we have some specific companies to insert people who are a bit away from the society. So this is what we call insertion of people in difficulty. So, for example, people who have a lot of difficulties to find jobs and things like that. So we offer them this type of jobs for 1, 2, 3 years to give them the possibility to find out afterwards better qualification jobs. So there are possibilities to give them jobs, but especially there are possibilities to give them much better conditions of living and working.
That's the way, Gordon. Thank you very much. Anyone have to complement? We have now 3 questions from the public. The first one is Carolina Medina. To Edmund, what is the percentage of the cost of the exhaust gas cleaning system?
What is the, I'm sorry, what?
What's the cost of the exhaust gas cleaning system?
Okay. Well, that's obviously very different from the country to country where you are at. Typically, we say if you take the total investment of a waste energy plant, the flue gas treatment is maybe 15%, 20%. It depends a little bit upon the system. There is no direct number because investment costs obviously vary a lot from country to country. But flue gas treatment can be in this range of cost. It's not a small portion of the investment.
Okay, thank you, Edmund. The second to Carlos Souza, to Mr. Gray. How do you see the integration of different sources of raw material to generate biogas and consequently energy? These sources are organic from the municipal solid waste and those from the rural environment. Well,
in our solution, it is typically not waste from rural environment, from agriculture or from manure and these kind of things. It's typically food waste, waste from the food industry, waste from restaurants. That is what is typically used in our technology. And this horizontal type digesters. So you can have other solutions for more liquid organic fraction from the rural industry, from the agricultural industry, but this is not the input material that we are using in our process.
Thank you.
But this is
much.
typically, as I said, in the ideal case, it's really coming from supermarkets, food markets, from restaurants, separated at the source to get a clean product, to get a compost and a liquid fertilizer that you can really use in the agricultural industry.
Thank you, Roland. I have a question to you. If you do not separate in the source, it's possible to separate in a machine separation and to use to produce secured organic, how can I say that, secured?
Yeah, of course. I mean, some organic fraction, of course, in some plants is separated by mechanical treatment. So it's mixed waste, and the organic waste is separated and goes then to the digestion plants. And of course, you will have a pre-treatment, a sieving, take out before and after the plant. So you're trying to get this plastic material, all that should not be in the compost. You try to take it out, but of course you will not succeed to 100%. So you will still have some small plastic material remaining parts in these fractions. So, but you can do it, yeah, of course, but you do not get the same quality. So you do not get the quality that can be used, let's say, in the agricultural industry. But you can maybe use it in parks, let's say, for such reasons. You can use it still, yeah. It is also a bit depending on local legal requirements and standards, of course.
Okay, thank you, Roland. The last question for Cordon, Charles Carneiro said that the organic fraction is separated by UK and French citizens.
Sorry, can you repeat? The organic fraction?
The organic fraction is separated by UK and French citizens.
In UK, not too much, but it's coming. In fact, there is a European regulation which is asking, like Roland has said in Switzerland, is asking to have separate collection of organic fraction, which is meaning, in fact, kitchen waste and green waste from the citizens. Nevertheless, kitchen waste or green waste is not all the organic part of the waste, because you have a lot of the things which are biogenic in the waste, such as textile, papers, and things like that. And when they are dirty, they are in mixed waste. So you cannot recover all, even if you have bio waste separate collection, you don't have a residual municipal waste going down to zero, as it has been said by Flavio at the beginning. If you have separate collection of packaging, separate collection of bio waste, of glass and so on, it's remaining residual municipal waste at the end, and which are polluted. And it has been said by Roland, you need to avoid this pollution going in the soil, for example, when you are doing compost. So the European regulation is asking now to promote, especially with large producers like restaurants or supermarkets, and to avoid to waste this food waste and kitchen waste, and to try to have organic recovery for that. But it's going step by step. And for example, in Paris, which is extremely dense population, for people, it's very difficult to have 3 or 4 poubelles, trash cans, in the very small kitchens. So it's really difficult to have this separate collection in very dense cities.
I have to give thank you to everyone right in the event. I will give you 1 minute to everyone to say goodbye, to say the final considerations. And please, first, Edmund, 1 minute.
Thank you very much for your attention. I hope it enlightened a little bit the situation, how it is in Germany. If you have any questions, I'm sure the organizers can forward my email address and you can approach me. Thank you.
Thank you very much. Cordon, please.
Thank you very much for the organization of this webinar, which I think was extremely rich in information. The same as Edmund, my email address is on the slides that you could see. And to conclude, I would say really waste to energy is a part of a circular economy, and it's a part which avoids circular pollution. So we need quality recycling, but we need the financing for the pollution, and which allows us to have renewable energy. So build energy from waste. Thank you.
Thank you. Cordon, please, one grave.
Yeah, thank you, Yuri, ABREN, for organizing this event. It was very nice to be part of it. As the other said, I mean, you can contact me. I'm also typically once a year, at least in Brazil, participating in the West Expo Brazil, which will most likely not happen this year, so next year. And you can also write emails in Portuguese, so I can easily understand. Most likely will respond in English, but you can write the emails in Portuguese, that's fine. And one recommendation for everybody, I mean, that you can Google, look at Google for Ilha das Flores. It's a very impressive movie showing the situation many years ago in landfills in Brazil. I think this landfill was in Porto Alegre. Very impressive how well people did live from the waste put on that landfill after animals have taken the good parts. So there is also, I mean, someone from Brazil showed me that and explained me that there is a development in Brazil, so we can think positive. So I mean, also in the future, I mean, in the landfills, in the sanitary landfills, there are no people living anymore on the landfill, living from that. Also, catadores cannot pick waste from there, and there will be place for the waste pickers, catadores, also in the future. Continuously develop all streams, recycling, separation, and thermal and biological waste treatment solutions. So all this has to go hand in hand, and takes a long time. So it's nothing that you change from today to tomorrow. It takes you well, it would count more than decades. You cannot do it as fast as they did it in China. So it will take you decades to develop all those solutions. So I think you should really start today, and there is room for everybody in this environment, actually.
Thank you, Roland, very much. Flavio, please.
I would like to thank you again, Yuri, for organizing this. And everybody, Cordon, Edmund, and Roland. I think it's been extremely rich presentations, and I do hope you'll help people understand better how important this is, waste-to-energy technology. And it does not compete with the others. As long as we have a separate collection gang, you put the right technologies on the right place. Everybody, as Roland has said, everybody has a place its place in the waste management system. All the technology. So I hope this will help people and other webinars that will come to help people understand how sustainable it is, and hopefully soon we're going to have a plant in Brazil as well. Thank you, everybody, for the collaboration.
Thank you, Flavio. Please, Antonio.
Thank you, Mr. Fleck, Mr. Cosholm, and Mr. Grail. ABREN has a challenge, a very, very important challenge, and a mission to help to change this market, this waste market. And I think Brazilians need a new way to manage their waste. And nowadays we are more or less like Mr. Cordholm cartoon. We are still with our square wheels, and we need to change to another kind of wheels. And thank you very much for everybody.
Thank you. Please, Rubens.
Well, guys, thank you very much once again, Mr. Fleck, Mr. Kyle, Mr. Cordon. I think, well, I make Bolognese's words mine as well. I think we have a huge challenge as it happened in other parts of the world. But I'd like to thank you, the three companies and the three directors, because for us, it's also very important to inform the Brazilian market, our public, authorities, institutions, government, industries. So I think this webinar, to have it in this high quality from the three presentations from you guys, it means a lot to us. I think it's a great step to change our future in Brazil. And I'm very thankful for that once again, guys. Thank you very much. And well, wish you a nice day. Thank you.
I have to be thankful to Edmund Fleck, Crystal Cordon, Roland Grail, Flavio Matos, Antonio Bolese, Rubens, Herbert IB. We are ending our second ABREN International webinar, Waste to Energy Technologies. If someone want to know more about waste to energy, call to us, send an email, send a message in our social medias. We are here to respond all the questions. We have this event will be organized by ABREN and supported by Global WtERT Council, BDA, Martin, Itachi, Kenin, BW Expo, NRG Hub, Ambiental Mercantil, Agenda Urbana Brasil. Thank you very much for you that are assisting this webinar. At the end, obrigado a todos, estamos à disposição. Bye. Bye-bye.
Bye-bye.